In this video, we're going to take a closer look at the three measures of central tendency: the mode, the median, and the mean. So as defined previously, when we talk about the mode refers to the most commonly occurring score within a distribution of a sample or of a population. But in terms of using the mode as a number to describe the distribution of the sample or of a population, this is most typically used when we have nominal scales of measurement. Now, using the mode as this descriptor, it does have some inherent limitation. So one such limitation of the limitations is that if there are more than two modes, it becomes difficult to interpret and to describe the data. There are some distributions that have a shape that looks more rectangular type, and in this case, there may be many modes, many occurrences of a wide range of different scores. And in that situation, the mode becomes very limited in describing that distribution. Furthermore, skewed distributions makes it quite difficult to use the mode as well. And just one example of a different type of distribution in this example, where the mode can be used effectively to describe, in addition to other quantities to describe the distribution, is what we call a bimodal distribution. And so as opposed to a normal distribution, which only has one peak, the bimodal distribution has two occurrences where a large number, and in this particular example, this is an ideal example, but in this example, we have two dependent scores where the same number and maximum number of people having those scores occur. It's just that the value of the dependent variable where this happens is different. And so in this case, even though we have two modes, it can be used effectively to describe the distribution. The next measure of central tendency is referred to as the median, and as the title suggests, here we're talking about a middle score. And that's the score that occurs at the 50th percentile. And so this measure of central tendency divides all the scores into upper and lower halves in terms of total number. So the median refers to the measure of the dependent variable where half the scores appear above, half the scores appear below. And so the advantages of using the median is that as opposed to having multiple modes, we could only have one median score. And that eliminates the problem that can come up when we have more than two modes. The median will also be centered around where most of the scores are distributed. And the median is not affected by extremely high scores or extremely low scores, which are simply referred to as outliers. So the median statistic is commonly used when we have measurement scales defined as nominal or ordinal, or we have interval ratio data that is highly skewed. And so using the illustrations on the bottom, starting with the bottom left-hand illustration, here we see our typical normal distribution, and the mode and the median both reside at the same point. And so with our normal distribution, it's symmetrical about the mode and the median. It's not indicated on this slide, but at this point, the mean would also exist. But in terms of the median is that score that captures half of the distribution scores below and the other half above. Things become a little bit problematic quantitatively when we have a positively skewed distribution, as we see on the right-hand side of the slide. And so with the positively skewed distribution, once again, we have a small number of very high scores. Now, of course, we have the mode still defined by the most commonly occurring score, remembering that our dependent variable is along the x-axis, and the maximum number of people exhibiting a particular score is found at the mode or at the peak of the distribution shape. The mean or the average dependent variable score will sit after the mode, and the median will be found between the mode and the mean. And we refer to this type of distribution as positively skewed because the fact that there are only a small number, so remember, y-axis, this is our frequency, how many scores occur at each level of the dependent variable. But here we see just a small number of scores on the very high end of our outcome measurement. And even though there's a small number of scores, these very small number of very high dependent variable scores are skewing the average in the positive direction. So when we think about positively skewed, negatively skewed, we talk about the small number of in this case, very high scores that is skewing the distribution towards, or skewing the average towards the positive side. And once again here with the median is that dependent variable score that divides up the number of scores total in our sample or our population on the lower end, and the other half resides on the higher end of the median. In terms of calculating the median, if we have a small sample size, so a small n, and we have discrete data, so in other words, non-continuous data, and in this example, we have an odd number of scores. And the first thing to do is to arrange the scores in a rank order. And when I talk about scores, once again, this is our dependent variable, our outcome measurement of a research study. And in this case, the median score is just locating the middle score. And so our example here, we have a study with a sample size of 5 people, and some outcome measurement was obtained where there were no fractional components. And we have scores that ranged from a low of 11 to a high of 20, and we place those scores in a ranked fashion. The median score is the location. That's just the score that occurs right in the middle. And so with that score occurring right in the middle, we don't consider the fact that we don't consider its magnitude with respect to the other scores. It's just that one that breaks it up into equal upper and lower halves. And if you notice, we have a score of 18, we have a score of 19, we have a score of 20, and the lower scores are quite a bit lower than 18 at 13 and 11, indicating and emphasizing the fact that this is a location measurement. Now, if we have, once again here, our small sample size, but now we have an even number of scores. And the first step, once again, is to rank order the scores. And what we're looking for is the location here, the halfway point. But with an even number of scores, we don't have one observation that is exactly in the middle. So what we have to do is deal with the closest scores, and there's only going to be 2 of them, that is closest to the middle. And so in this example, our median is right there. Our median is located is right in the middle of all 6 scores, but there's no observation here. So in this case, we have to compute the median as the average of the two scores on the low and the high end of it. So we would take the 9, add it to 11, divided by 2. And so our median score, we would say, is a 10, even though we don't have an actual observation at 10. But the median score provides a magnitude and a representation of our outcome measurement, as well as, and this is quite important, the location in describing a set of data. Now, moving on to arguably one of the most commonly used measures of, or probably the most commonly used measure of central tendency, is the average or the mean. Very commonly used, not just in research, but in everyday life. And this refers to the score located at the mathematical center of a distribution. So this is a little bit different than the median, where the median is a physical location at the center, whereas the mean is a mathematical center of a distribution, also referred to as the average. And so the mean does take into consideration all of the scores in a distribution. And in our equation, which we're going to see shortly, X refers to the raw score of one research participant or one unit in our sample. And X bar, the bar is slightly moved over to the right. We don't want to do that. This is a PowerPoint issue, but the bar should be centered right over the X. And this is the symbol for the average of all the participants or all the units in our research study. And so once again, we've seen this earlier in a previous lecture, but we have our uppercase Greek letter sigma as the symbol for summation. So what we're going to do here is we're going to add up all the x's, and x is the raw score. And this is a abbreviated, handy way of indicating that we're doing an addition in the numerator. We could alternatively have written this that if we had 5 research participants, we would write the numerator as x1 plus x2 plus x3 plus x4 plus x5. And whatever the outcome scores for each of those 5 participants, we would add them all up, divided by 5, if 5 was our sample size. And so just to round out this video here, we're just going to do one last review and summary of positively skewed and negatively skewed distributions. And so as a summary here, we would use the mode as our measure of central tendency. Definitely if we have nominal data that and data that is distinctly bimodal. So if we have a distribution with 2 peaks, then we would use the mode as part of our quantitative description of our study. In terms of using the median, if we have data that are ordinal in terms of the scale of measurement, we would use the median as a measure of central tendency. If we have ratio or interval data that is very clearly skewed in its distribution, then the median is often recommended. We would often use the average if we have interval or ratio data that approximates a normal distribution. So it's important to note that in real data that we collect as part of a research study or as part of some work with an organization, perhaps a customer opinion survey that takes measurement along a ratio or interval scale, the data will most likely not be exactly normally distributed, but as long as it's close enough, then the mean is recommended. So just to review graphically the negatively and positively skewed distributions, we see the mode is defined by the single highest point. That's consistent between the 2 types of skewed distributions. The median sits on the side of the mode where the very pronounced tail exists. We see that here. We see that on the right-hand side. And the median will be positioned between. So when you think about median, think about middle with a skewed distribution. Handy way to remember this, the median being middle. It's always going to be between, in the middle of the mean and the mode in these skewed distributions. Remembering that the mean is most sensitive to these outliers in these very pronounced tails. In this case, on the positive side, the distribution will skew the mean in that direction towards in the positive direction. And in this type of distribution, the small number of very high scores will skew the mean in the negative direction. So this ends this video related to our definitions of the three measures of central tendency.